Okay, so here's the deal. Scientific notation. It is not difficult. You just need to think. Think. That's all I ask of you. Okay? Scientific notation is used for really, really big numbers. Because when a really, really big number happens, do you want to keep writing that big number so it goes like onto the 3 pages and so on and so forth? No, you want to write it so it's nice and small, but you still want to know what it means. Believe it or not, you've seen scientific notation before because your calculator puts things in scientific notation that are super big. If you've ever seen like a whole number and then in the end has like time and then a 10 and then like a little number before on like your calculator, okay, if you've ever done that, that's scientific notation. Okay, so a few things about scientific notation that you need to know. So 2 vocabulary words. Okay, scientific notation and then standard notation or standard form. Yep. What's that? Oh, maybe. We maybe did that last year. So here's the good news. Today we're only going to be using tens. 10 to the 7th power, 10 to the 6th power, 10 to the 5th power. It's never going to be anything other than 10. It's never going to be anything other than 10. Standard form is when you actually have to write out the whole number. So like what's going to happen is it'll say write this in standard form. So it's going to give you a number in scientific notation. You actually have to write the number. Okay? Scientific notation is when they give you a long number and you have to simplify it and make it shorter. Okay? And I'm going to show you how to do that. What's that? Not necessarily the zeros, no. Okay, and I'll explain why in a second. Okay. So, first of all, let's just talk about what these numbers would be in powers of 10. So, if I have 1, that would be 10 to the first power, right? This would be 10 to the second. This would be 10 to the... Oh, I'm sorry. No! You guys. There we go. Sorry, 10 to the 0. This would be 10 to the first. This would be 10 to the second. 10 to the third, 10 to the fourth. Now, in reality, you might say, oh, well, that's how many zeros are on the end. But truthfully, that's not what it is. It's how many times the decimal moved, okay? So if I have a decimal behind that 1, how many times did my decimal move to make it a 10? 1. That's what that exponent means. It doesn't mean how many zeros are on it. It means how many times the decimal moved. So, no. Nope. So always get in your head right now. It's how many times that decimal moves. Okay. So here, it moves 2 spaces to the second power, 3 spaces, 4 spaces, and it really, like some of you might say, well, it works for that tens. How come I can't just do that? Well, it only works for the tens. It doesn't work for anything else. That's why we can't always rely on counting the zeros. Okay. Yep, all tens. That's it. Okay, now the reason why we're doing this is because I just kind of give you an example of why we're using those tens. Okay, so let's talk about 100. What is that? It's be 10 to the second, right? Okay, so this is 3.4 times 100. You know, to solve this problem in your head, how many times do you need to move that decimal? 2. So I know 1, 2 would be 340, correct? Okay. What about up here? How many times am I going to move that decimal? 3. So you already have the basis of scientific notation already. Because you know when you multiply something like this, that's how many times you're going to move that decimal to get your answer. Yep. Right here? 1, 2. 1, 2. Yep, and that's where it stops then. Like I said, it's not how many times that how many times zeros goes on there. It's how many times that decimal moves. Okay? So this is basically the basics of scientific notation today. Okay? So I'm going to show you how to do this. So what's going to happen is you're going to be giving a number. This is a number in standard form right here. What's standard form mean again? Yep, the big number. So to do this in scientific notation, the first thing I want you to do is I want you to put the decimal where it should be. Where should a decimal go in that number? No. Where should it be? If I look at the number, it should be at the end, right? It should always be at the end. Okay, we're going to put it there. Now to write in scientific notation, I need to look at this number and I need to see how many numbers are in this number that that are between 1 and 9. Where are the numbers in this big number that are between 1 and 9? The front. What numbers? 2, 3, and 4. So I'm going to focus on the numbers that are basically the numbers that become before all the zeros. Does that make sense so far? So I'm going to look at the numbers that are before all the zeros. And then what am I going to do is I'm going to start forming it into scientific notation. My job is to take this number and make it between 1 and 9.9. Where can I put a decimal in this number that's going to make it between 1 and 9.9, Brian? After the 2. Okay, that's where I'm going to start my decimal. So I'm going to put them there. Okay? Yes, ma'am. How do I know what? How do I know that this is the answer? Or what do you... Yeah, I don't know that yet. I'm not sure yet. Okay? Just hold your question. Yep. It's going to be between this. It should be between 1.0 and 9.9. In other words, it's always going to go between the first two numbers. It's always going to go between the first two. Because let's say I write it like this. Oh, is that between 1 and 9.9? No. Is this between 1 and 9.9? 23.4? No. So it's always going to go between the first two numbers, you guys. Okay? Does that make sense so far? Okay, now let's go back to our big number. Let's say you put that decimal right here. My job now is to count from where I put that decimal to where the decimal should be in that big number. So I'm going to start here, and how many spaces is it? 1, 2, 3, 4, 5. Look it. 10 to the 5th. This is my answer, all together. All together. So it's going to be that first part, and then it's going to be times 10 to the 5th, because that 10 to the 5th tells me I moved my decimal how many spaces? 5. And when I did that, did I come out with my big number? Mm-hmm. Yep. So this is the answer. Part of it, yeah. Okay, so let's do another example. No, not necessarily. It's pretty much all easy. We're either going to go from this to scientific notation, or they're going to give us scientific notation, and we have to write in a big number. That's all. Okay, so let's try this number. Okay, so 8, 7, 4, 3, 0, 0. First thing I need to do, make sure you got a note in your notebook. Hint, hint. I'm going to put a decimal on the end, because that's where my decimal should be. And then I'm going to look at my number and say, okay, what numbers come before all the zeros? 8, 7, 4, 3. Okay? And I need to make that between 1 and 9.9. So where's my decimal going to go? Yeah? Good. Okay, very good. Times, I'm always going to do times 10. And then I'm going to figure out how many spaces I move my decimal, and that's going to be my exponent. Is it 5 again? 5. Yep, done. I just wrote this number in scientific notation. Okay? Oh, I don't know. Can we do a few more? Can I do another one with you first before we do that one by yourself? Let's do this one. Are there any zeros in here? No, but that's okay. You can write any number in scientific notation whether it has zeros or not. So here's where my decimal should be. But I got to put it between that 5 and the 3. Times 10. Yeah, 10 to the 3rd. Very good. Okay. So it doesn't matter if there's zeros or not. You're just looking for those numbers that are between 1 and 9. Another question I had before I let you do this one, Maddie. Can I erase this, you guys? What if I have a number that's like this? Okay, I still have to include that 0. I'm talking about all the numbers before my whole group of zeros. So even though there's a 0 in there, that's okay. It can stay. It would still be included, yep. So basically, if it's still surrounded, or it's like a sandwich, you know what I mean? Like a 0 sandwich or whatever. Yep. So this would be 1.032 times 10. I don't know. Let's see. Is it 1, 2, 3, 4, 5, 6, and 7? Yep. Done. Okay. So do you want to try this one? Okay, so you go ahead and try that one. So just a quick reminder, these are standard form. So we're taking these from standard form to scientific notation, okay? Okay. All right. There's 4 zeros. Yep, and we're going to do that next. That's actually easier. Backwards? Going backwards? So much easier. Oh, yeah, there's nothing harder than this. This is as hard as it's going to get today. Yeah. Well, that's what we thought yesterday, right? All right, somebody tell me what this is in scientific notation. Who's got a good guess? Jacqueline? Times 10 to the... Yep. Yes, this is your answer. You have to have this right now. I can't tell you how many times I've corrected. I've done this lesson multiple years. Kids will do this. That's not the same thing, okay? You have to include that 10. No, because this is including that scientific notation. I have to have that to know what my number's going to be if I got to go backwards. Okay, so I have to have that whole thing. All right, let's go the other way now. Okay, so now we're going from standard scientific notation to standard form. So we're going to write out the big number now. This is what I would do if I was you. I would write this out. This is what I would do. I'd write this out. And then it tells me how many times my decimal is going to move. How many times is it? Okay, so this is what I would do next. I would start at that decimal and I'd go 1, 2, 3, 4, 5, 6. That's for my decimal. And then I put zeros in there. I'm done. That's it. Yep. Yes, Hunter. Yes, that's the next time I'm going to get to. It's just as easy. Trust me. Okay, so what about this one? How many times am I going to move my decimal here? So really, my answer is going to be this, right? Okay, because I have to move it 3 times. This, even though it's a negative, it's fine. Keep it a negative. Not a big deal. But I'm going to move 4 times. 1, 2, 3, 4. See how it's not how many zeros you put on? Okay. Yep, still negative. So it'll be negative 17,000. That's it. Yep. Yep, that's it right now. What about this one? Oh, we don't even know what the number is. That's going to be a big one. 7, 5, 6. So it starts here. So 1, 2, 4, 5, 6, 7, 8, 9. That's my number. Yeah. Not too difficult, right? Okay, so this is probably the easiest way, right? Going from scientific notation to standard. Okay? It's fine. Yeah, so did a lot of people. You're probably not the only one. Can I go to the next slide? Okay, so we talked about positive exponents. In your notes, write this down. Positive exponent, you're going to move to the right. And we just talked about that. Negative exponents, guess what? You're going to move to the left. So we just talked about those. Let's check those off the list. Okay? Now we're going to talk about the negative exponents that you guys are wondering about. Remember how we talked about negative exponents? It's a really, really small number. Okay, it's going to be the same way today. When you have a really, really small number, you're probably going to have an exponent that's negative. So let's look at this one. I would write this in my notes if I were you. 0.00, so there's 4 zeros and then 3, 4. 0.000034. And we're going to write that in scientific notation. Now you're going to start doing this just like what we did before. Find the numbers that are either right after the zeros. What numbers are right after the zeros? Okay, so that's the number that I'm going to make in between 1 and 9.9, so 3.4, right? Times 10. Now, if this is where I put my decimal, that's where my regular decimal is. I'm going to count 1, 2, 3, 4, 5. And since I moved to the left, it's going to be a negative 5. Okay? It's the same thing, only we're going the other way. So when you go to the right, you're going to be a positive. When you go to the left, you're going to have a negative. Mm-hmm. Yep. And to look for the numbers like, okay, I know that's really small. That's way lower than 1, so it's going to be a negative exponent. Okay? Don't forget the 10. Mm-hmm. Yeah, positive, right? Yeah, kind of like the number line. Let's practice some of these, shall we? Let's practice some of these. Let's practice. So let's look at this one. So I have 0.00568. So the numbers I'm going to use in my beginning part are that 5, that 6, and that 8, right? So 5.68 times 10, just always get in the habit of that, times 10. So this is where I put the decimal. 1, 2, 3. Negative 3. Why did I start? Because that's where I'd put it. Because if I put it between the 68, I get 56.8. And it has to be lower than 9.9. Okay? It's the same rule still goes. It still has to be lower than 9.9. What about this one? Somebody help me out. Okay? So it'll be 2 to the second power? Very good. This one, I'm going to put it between the 9 and the 7 times 10. Geez, let's see. So 1, 2, 3, 4, 5, 6, 7, and 8. Negative 8. I know, it's tough. Even this one, it would still be 9.86, but it'd be times 10 to the negative first. Okay? How are we doing so far? So far, so good? Let me see if I got any more slides. We're probably going to go the other way here. Oh, yeah, the other way. So now we're going to take scientific and go to standard, but I got a negative exponent this time, so I would do the same thing. I would write the first 2, and I'm going to move 3 to what way? Left. 1, 2, 3. That's my decimal. There are my zeros. Do you want to try a few yourself? Why don't you do the bottom 2 yourself? No. Okay, you ready? Okay, so somebody that I haven't heard from yet today, Larissa, what is this answer? Everybody agree? 1, 2, I did 2. What about this one? Rain? Everybody agree? 3 zeros in front? Oh, I'm 4. My bad. But just so you know, remember, it's not how many zeros you put, it's how many spaces that decimal moves. And that's going to be really, really important in the next few lessons. Okay? Sure. That works too. Okay, so if I had this, 1.6, and I move it 2 spaces, 1, 2. Gotta remember there's a space in between that before that 1 too. Okay? Okay. Okay, let's look at your homework. Let's get your book out and let's just take a look at it together.